Assalamu alaikum, welcome to SAT practice. So today we are going to do another set of number theory problems. So let's start with this question. So we have if x, y, and z are consecutive integers. So what does mean consecutive integers? So we have 1, 2, 3, 4, 5, 6, and so on. This is a consecutive integers. And same thing. Uh, 0, minus 1, minus 2, minus 3, minus 4, and so on. This is consecutive integers. So if they ask me three consecutive integers in the order, so it can be either 2, 3, 4, or 1, 2, 3, or 0, 1, 2, and so on. So those are three consecutive integers. But what is the general notation of three consecutive integers? So consecutive integers, the notation is the following. So either we do n plus 1, n plus 2, n plus 3, n plus 4, n plus 5, you see? So those are consecutive integers. Or we can do n minus 1, n plus 1, n plus 2, and so on. So any way you do it, it's okay. So if they ask me for three consecutive, so I'm gonna pick those three for example. So I have those three consecutive integers, and n can be any integers, can be two or anything. So it's still three consecutive integers. Now, so we know that the integers, what do we have? We have alternating one odd, the other one even, odd, even, odd, even. So if I take two consecutive integers, so one of them should be odd, the other one should be even, and vice versa. So that means I will have what? Either we have even, odd, even, or we can have odd, even, odd. So those are the two choices we may have. So if I take those two and I sum together, we know that the product of even and odd is even. So the first choice, the product is even, is true. If I take the first and the last, so I have the first is n minus the last n plus 2. So I will have n minus 2. So this is cancelled out, which is minus 2. And this is even. So the second one is true. So x to the power z is even. So here in that case, I will give you an example. If I choose x equal 1 and I choose z equal 2, 3 for example. So I will have 1 to the power 3 is 1, and this is x and this is z. So this is odd. This is not always even. So that means the third choice is not true. So my answer will be D. All right, next question. So here this is a lot of operation. So oh, this is an equations, but we have absolute value here. So we just need to evaluate the absolute value. That's so for x. So here we have minus x minus 2 equal minus absolute value of minus x minus 4 absolute value. So here I'm going to do the order of operation here in order for me to find the value of this expression. So I got minus x minus 2 equal minus absolute value. Here it's going to be 4, so it's going to be minus 4. Absolute value minus 4 is 4, so it's going to be minus 4 here. So minus x minus 2 is 4, so I add 2 both sides. So I got minus x equal minus 2 divided by minus 1, then x will be 1. So this is, oh, then x will be, then x will be 2, not, not 1. So x will be 2. You see, this is because it's too easy, so I didn't pay attention to the answer. So be careful, so be awake. Don't make the same mistake I just made. So if it's too easy, so stay awake to make sure that you don't make silly mistake. All right, next, if the sum of two prime number x and y is odd, so if I have x plus y is odd, and both of them are prime. So if both of them are prime and the sum is odd, what does it mean? We know that the only even number which is prime is 2, and the rest is 3, 5, 7, 9, and so on. They are odd. So we know that even plus odd is odd, but odd plus odd is even. So therefore, one of them must be 2. So what do we have? We have 2 plus y is odd. So it's exactly what do we have. So if I take the product of x and y, of course I will have 2 times y is the product, then it's even, so it's divisible by 2. Next question. So if x plus y over x minus y equal 3, and x and y are integers, so which one is the following? X divisible by 4. So, but let me see what I can get from this statement. If I cross multiply by x minus y, so I will have x plus y equal 3x minus 3y. Now I add 3y both sides and I minus x. So I got 4y equal 2x divided by 2. So I have 2y equal x. So 2x is twice y. That means x is even. And do we have that choice here? X is even number, yes. So x is even. Next, a two-digit even number is such that reversing its digit creates an odd number greater than the original one. So this is the idea. So I have two-digit number, and that number is even. So if I flip or I reverse the order, I will have yx, and this is greater than xy. Now, which one of the following cannot be the first digit of the original number? Alright, so what is yx and what is xy? So this is the tens, this is the ones. So we know that, for example, 25 is 2 times 10 plus 5. So if this is my x, this is my y, this is going to be x times 10 plus y. So this is exactly how I'm going to use, this is exactly how I'm going to try to find out which value cannot be in the first digit. So here what I do, this is going to be 10y plus x is greater than 10x plus y. So I minus y both side, minus x both side. So I got 10 minus y is 9 is greater than 9x. So 9y is greater than 9x, so I divide both sides by 9. So I got y is greater than x. So, and those are the digits from 0 to 9. That means the second digit should be always greater than x. So this means the 1 should be greater than the 10. So which value can x can never take is the 9, because 9 is the greatest digit. So 9 is my answer. Next one. So let's A, B, and C be three integers. So we know that A is a perfect square. That means A is equal a number square. And we have A over B is the same thing as B over C. So which of the following must be true statement? Alright, so if I cross multiply, I will have A C equal B square. If I divide by A both sides, I got C equal B square over A. But we know that A is a perfect square, so I'll substitute A by N square, so C will be B square over N square, which is the same thing as B over N square. And this shows that C is a perfect square, and the answer is C. Next question. So if n is greater than 2, then the sum S of the integers from 1 to n can be calculated by the following formula. So if I have 1 plus 2 plus 3 plus till n can be any numbers, so it can be calculated using this formula n times n plus 1 over 2. Alright, which of the following statements about s must be true? Is it always odd? Alright, so let's see if it's always odd. So if I choose 1 plus 2 plus 3 plus 4, so it's the same thing as 4 times 4 plus 1 over 2. So which is going to be 20 over 2. This is 10. No, it's not always odd. So this is not always true. Is it always even? No, it's not always even because I can just uh, choose, for example, 1 plus 2. You see, if I do 2 times 2 plus 1 over 2, that means I'm applying the formula. So I'm going to be 2 times 3 over 2, which is 3. You just need to add those two. That means this is not true. Must be prime? No, because you see the sums can be even, like here. That means it's not prime. It's not a prime? Yes, it's not a prime. It can be any number. So perfect square? No, as you see here, none of them is perfect square. So those are not good answers. So that's me. The answer here is D. Next, if n is a number greater than 5 and multiple of 5. Alright, it's greater than 5 and multiple of 5. What are the number greater than 5 and multiple of 5? So we know it's 10, 15, and 20, 25, and so on. So then what is the remainder when n is divided by 10? So either we have the remainder is 0 or the remainder is 5. So we don't have 0 here, but we have 5. That means 5 is my answer. Next question. Which of the following could be the difference between two numbers? Could be the difference between two numbers, both of which are divisible by 2, 3, 4. So if it's divisible by 2, 3, 4, that's mean divisible by the LCM of 2, 3, 4, which is 12. You see? So divisible by 2, 3, and 4, that means it's divisible by the LCM of 2, 3, 4, which is 12. So I'm going to choose which one of them is divisible by 12. This is not divisible by 12. B is divisible by 12. So B is my choice. A number, when divided by 12, gives the remainder 7. So we know that the Euclidean division is the dividend equal the divisor times the quotient plus the remainder. So a number x divisible by 12, it's equal a number plus remainder 7. So it's going to be this notation. So if the same number is divisible by 6, then what is the remainder? So if I divide that number by 6, that's, I mean, I will have 6q1 plus r. So what is the remainder here? So I work out this statement. So I have x equal 12q plus 7. So what is 12 is 2 times 6, yes? So this will be 6 times 2q. So now I create my divisor, which is 6. Then how can I pull out the remainder from here? We know that 7 is greater than 6. So I can create this operation. So I add 6 plus 1, which is giving me 7. Then I take 6 as common factor here, plus 1. So this will be my quotient. So this will be my quotient if I divide by 6. So the remainder is 1. Next question. Let x be two-digit number. The sum of digits is 9. So I have x is AB. So I know that a plus b is 9. Then the sum of the digits of the number, what is this? Then the sum of the digits of the number is, all right, so if I add x plus 10, which is my new number, what's going to be the sum of the digits? All right, so if the sum digit is 9, that means the number is a multiple of 9. And this is something that we learn in I think in 6th grade. So if the sum of the digit is 9, that means the number is divisible by 9. That means it's going to be a multiple of 9. So what are the multiple of 9? So which are two digits. So we have 18, 27, 36, 45, 54, 63, 72, 81, and 90. So those are the two digits that are divisible by 9. And the sum is 9. The sum of the digit is 9. So if I add 10 to each one, so here I will have 28, 37, 46, 55, 64, 73, 82, 91, and 100. If I take the sum of the digits of those is always 10, and the sum digit of that one is 1. So that means E is my answer. That's the possible. I have the two possible way, which is either the sum digit is 1 or 10. So I hope you got the idea about the review today. So thank you for watching the video and see you for another SAT practice inshallah. Thank you for watching and Assalamu alaikum.